Hi, today we are going to talk about doubly linked lists. So in the last video, we saw the single linked list. In that list, we have nodes. Every node is pointing to the next node. We call the first node as a head and the last node as a tail. And we saw how we can use the linked list, singly linked list as stack and also as a queue. Today, we will discuss the doubly linked list. It's It has node as well, but every node has two pointers. Every node is pointing to the next node and also to the previous node. So node B is pointing to the next node, which is node C, and also pointing to the previous node as node E. So in this doubly linked list, I can go in this direction to the right direction, and also I can go back. But here in the single linked list, you can only use one direction to go from left to right. So in the single linked list, we have head and tail. But we saw in the last video, because of the head or tail, we have to deal with some special cases, like if the list is empty or the list has one operation, then we have to do some special handling for head and tail. If we want to make head and tail in the doubly linked list, we will have more special cases, and we have to deal with so much if statements. So to avoid this, we have something called dummy node. The dummy node is just a node with no data, and this dummy nodes appears before the first nodes and also appears after the last nodes. So it's like the linked list now is like a circle. A, then B, then C, then D, then E, then dummy, and then A, and so on. So it's like a circle. So this dummy node will simplify things. So the dummy node is added to avoid special cases, and we will not have explicit head in the doubly linked list. The head is just the node before the after the dummy node. So head is the node after the dummy node, and the tail is the node before the dummy node. So let's try to see how to make a doubly linked list. The first thing is that we create a class node. Let's create a new project. The name of this project doubly linked list demo 0, and then for this we create new class. The class is node, the node class. In the doubly linked list, the node class will have so let me do these things. So the node class will have data of type object, and also will have node pointing to the next and pointer pointing to the previous node. So this is the node class, and then we create. So this class looks like the node in the singly linked list, just we added a previous link. Now we create new class. The name of this class is doubly linked list. In this class we will have integer n, number of elements in the lists, and we will also have a dummy node. We don't have head and tail, but we have dummy nodes. So we have dummy, and we have a constructor public, same as the class name. In the constructor we make n to be 0, and we create a dummy node And we will make the next for the dummy node dot next to be the node itself, because at the beginning the list is empty. So the next of the dummy, there is no next. The next is dummy is just the dummy itself, and the previous of the dummy dot previous, it's just the node itself. So this is the constructor of this node. And now we will define the list operation. We have 5 list operations. The first one is easy. It's the size operation, where we just return the size. Public, it return integer size, and it just return n. So this is the first operation of the 5 operation, and then we need get. So we need to write a method that return object. It's called get, and it take integer I. So to get the node, we want a helping method. It's called get node. Let's define a helping method. Public node. This method get node return a node. It return a node at position I. So how we can make this get node? First we have to define node. Let's call it M equals to dummy. Okay, and then we have to see if we have 2 options. If this I, so we can go to position I from the beginning of the list or from at the end of the list. Which one is better? It depends on the location of I. So if the list is 100 and I want to get node 20, it's better I go from the beginning, because I just move 20 steps. If I want to go from the end, I will move 80 steps. But if I am looking for a node at position 75, it's easier to go from the end, because I will walk 25 steps. So how to decide this? If I is less than or equal n over 2, if I is in the first half of the list, then I have to go from the beginning. So dummy, M equals, so actually I don't need to make it dummy, just I define it, and here it's equals to dummy dot next. So I will make M to be the first node, because dummy is next is the first node, and then I will make a loop int I or j, because I have a variable called I, equal to 0, j less than I, and j plus plus. So I will move from position 0 to position I minus 1, and every time I will make M equals to M dot next. So I will move M to be the next node, and so on. So in the last iteration, M will be at position I. So, and then I just will return M. But else, if I is in the second half, so I will do M equals to dummy dot previous. So in this case, I will just get the tail or the last node, and then I will do a for loop int j equals to n minus 1. I will start from the last node, and I will stop at position I plus 1, and then j minus minus, and everything every time I just doing m equals, I'm going back, so m equals to m dot previous. So either I get m using this loop from the beginning or from the end. At the end I will just return m. So this will return the node. So this method gives me the node I'm looking for. I will use this method in many places, as you will see in this video. So here what I am doing, if I want to get position I first, I define node m equals to get node at position I. So I use this method to get the node, and after this I will return object, return m dot data, and with this I just get the data that I want. So this is the method get. It's one of the list operation. How about set? Set is also easy. Public void set. I want to set position I to have the value object x, to have the value x. How to do that? Again, I will just get the node, search for the node, and then I will set m dot data to be x. So this is the set and get operation. So m sorry, I name it as a date, but it should be data. Let me change this. So it's data, not date. So data, and that's it, I think. Okay. If we look to the get node, what's the big O notation for this method? It's the big O notation is something like big O of n minus I or big O of I, the smallest between them. So it's big O of minimum between I and n minus I. If you want to look to this get method, it's the same because I'm calling get node. If I want to call set, it's the same because I am calling get node. So now I did the size, get, and set. Let's do the add and remove. For the add, I want to define a helping method called add before. So this add before, I give a node w, and it will add some object before the node w. So first I need to define the node that I want to add. Let's call node m equals to new node. So I create a new node. I will make m dot data equals to x. So I create this node with this data, and then I need to add this node in the middle of the list. To add this node, I need to modify the links, the next and the previous, for this node. So m dot next should be equals to w. So this w is the node that I want to add before it, right? And m dot previous should be equals to w dot previous. I want the previous node of the new node to be the previous node of w, because I want to make the new node between w and the previous node. So with this I fix the links for the m, but still I need to fix the link for w. So w dot previous Before it was pointing to the previous node, but this should be changed because now u should, the new node m should be the previous node. So now the previous of w should be m, and the node before m, okay, so the node that was previously before m, so w dot previous is equal to m. And now the node before m, so m dot previous, the next of this node, it was previously w, but now it should be m. So I link the previous node to u, and I link u to the next node, not u, sorry, m. I linked the previous node to m, and I linked m to the next node w, and also I fixed the pointers for m. So these 4 pointers has to be fixed so that I can add a node, and then just I increment n. So the running time of this add before is big O of 1 because I don't have loops, it's just constant number of operations. And now I want to use this node, public void add at position I object x. So then I can just call add before. First I have to look to find node m equals to get node I. So I am getting the node at position I, and I want to add before. I want to add before m. Add before m, and I want to add the value x before m. And with this I'm done with the add. If you see, add has get node, so the big O notation is the minimum between I and n minus I. So now I have add. I just need now the remove. To do the remove, I need a method called remove node. It returns a node. Let me remove node at position I. In this case, I will just remove this node. Sorry, remove node is actually not returning anything, but it will remove a certain node. Let's call it node m. So how to remove node m in the middle of the linked list? So m dot previous, I have to go to the previous node and change the next to this node to be m dot next. So the next of the previous node should be the next, and m dot next dot previous should be m dot previous. So I'm changing the previous of the next node to be the previous node. So I'm fixing just the links, and then I decrement n. So this is the remove node. Now I need to make my remove method. That's part of the list interface. Object remove, and then int I. I will define node m equals to get node I. I will get node I, and then I will remove node m, sorry. I will remove m, and then I just return m dot data. So with this, I'm removing the node M. So let me check this error, change the message. The name is remove node, so that I can remove this node. And now I have finished 5 main methods in this interface: the size, the add, remove, and set and get. If I want to make example, so I define doubly linked list, let me call it new doubly linked list, and then d dot, I can add now I can add the names, for example Lamar at position 0. I can add again at position 0, let's say Sarah. I can add Layan. I can add at position 2, let's say we add Habiba. So now I'm adding Lamar at position 0, and then I add Sarah before Lamar. So Sarah will be 0 and Lamar is 1. I'm adding Layan at position 0, so Layan will be 0, 1, 2. And then I'm adding Habiba at 2, so Habiba will be the 2 and Lamar will be the 3. If I want to print them, it will be it will be Layan, Sarah, Habiba, and Lamar. I can just make a loop to print them. Let's say less than 4, or I can make it less than the size I++, and then system.out.println. I just print d.get I. So as we said, we will print first Layan, Sarah, Habiba, and Lamar. Layan, Sarah, Habiba, and Lamar as expected. I hope this video is clear, and talk to you in the next video.